So this question states, determine the concentration of hydronium ions. So basically find H plus or H3O plus. They both mean the same thing. For a neutral solution at 25 degrees Celsius and 50 degrees Celsius. Okay, now what we should realize here is, what does neutral mean? Neutral means that your compound is not acidic or basic. And what it really means is that H3O plus equals OH minus. They're both the same thing. And because they're equal to each other, we're going to set them both to an unknown variable. We're going to set them to X. And then what we're going to do here is, we know at 25 degrees Celsius, Kw will be 1.0 times 10 to the negative 14. So at 25 degrees Celsius, that's what our Kw is. And we just said that H3O plus and OH minus are equal when the solution is neutral. And we're going to set them both equal to X. So then you're going to say X times X really means X squared. And you only want to find X, not X squared. So take the square root. So in this case, X equals 1.0 times 10 to the negative 7. That number right there represents my concentration of H3O plus. And technically, because it's neutral, it also represents the concentration of OH minus. Now, if we wanted to do it at 50 degrees Celsius, we'd have to realize that since the temperature changes, Kw changes to this new number here. So we're going to say 5.476 times 10 to the negative 14. Same exact process, equals X squared. We just want X, so we're going to take the square root of both sides. When we do that, it's going to give us a final answer of X equals 2.34 times 10 to the negative 7. Now, so remember, this is important to know because Kw equals H plus and times OH minus. This equation is important because if the temperature is not given, assume that Kw equals 1.0 times 10 to the negative 14. If you know H plus concentration, then you know OH minus concentration because Kw will be our constant. And vice versa. If you know OH minus, you can find H plus. This is the relationship we need to understand. And these are the beginning steps for us to figure out the pH and pOH of different types of aqueous solutions.